Okay, great. Hey, everyone. We're going to go ahead and get started here with the first presentation of the day with Backtrace. For those of you kind of around, feel free to start sitting down here. We're going to do a live demo of Backtrace and tell you a little bit about the platform. Awesome. I'll wait just 1 second while people are sitting down. Awesome. Okay. Great. If you want to see a demo of Backtrace to be able to manage your video game crashes, feel free to come to the stage area. We're going to go ahead and get started. My name is here. I'll wait 1 second. See if anyone comes. Yeah, that's not in the house. Okay, let's get started. My name is Abel. I'm the CEO of Backtrace. If you want to find me on Twitter, my name is null0. And I'm joined here today by Chris Bruning, solutions architect, works at Amazon Game Services, one of our key partners here. So if you've heard of Hard, then you've heard of these guys and what they're doing. Is your microphone on?
You carry on.
Okay.
This one on seems to go off.
Hello.
Hello? Yeah.
All right. Great. You guys hear me now? Okay. Awesome. So if you're a game developer, if you're a studio, or you're interested in making sure your video game doesn't crash, then this talk is for you. Hopefully by the end of this talk, what you'll understand is that this stuff isn't incredibly difficult. If you use something like Backtrace when you're developing a game, then you can manage the onslaught of crashes. Before we dig into the actual demo, I just wanted to set the scene as to why you should be concerned with video game crashes and why Backtrace might be relevant to you. Error management is really difficult. Imagine you're playing a video game on a PC and the game crashes. If you're in alpha or beta, this can be incredibly meaningful to your end users. That same user could go on a forum, complain about the video game crash, and without any visibility into what's going on, you're kind of at the mercy of what the user reports back and your own intuition here. Furthermore, because the technology there doesn't give us the full visibility that we want, the way in which we collaborate and the way in which we use this data is hindered by our ability to collaborate with existing systems. So if you're using something like GitHub or Jira, you're constantly going back and forth between these systems to be able to collaborate and get to the root cause. Just to put it frankly, existing technology doesn't allow for the flexible analysis of these video game crashes across platforms and deployments. If you're a game developer, this has very stark implications to your end game. Some of the users that use us today use Backtrace to be able to reduce the amount of refunds that their end users actually request, keep their user retention rates high. If your video game's crashing within the first 5 minutes of them playing, then it's often the case that they'll go and complain. They'll go and ask for a refund. And without that visibility that Backtrace can provide to you across platforms and environments, then you're at the mercy of the user. So enter Backtrace. It's a turnkey, drop-in crash reporting and analysis solution for video games. It gives you true cross-platform crash capture. It lets you add custom attributes, as many as you'd like, to be able to add contextual information to the crash. So for example, if you want to know which specific platform, which operating system, which game level, which driver, all of these things can be added to what's being captured in the context of the crash. Backtrace then allows you to act on this data based on impact. You can search across these dimensions, and you can make sure that your major bugs don't take your game down. And then finally, because we arm you with all this information and integrate into your workflow, you can gear up your team. You can get your game out faster, and you can be confident in the quality and the resilience of your video game in the event of a crash. Here's a small little diagram to show kind of how you should think about Backtrace. Across all platforms, Mac OS, Linux, Windows, Lumberyard, and across different languages, you can send data to the Backtrace database. This can be hosted on your own servers, or it can be hosted by Backtrace as a service. And with Backtrace, it provides you automated symbol management, advanced deduplication. So imagine you have the same crash across platforms. Our algorithms will be able to do similarity analysis to say it is the same crash. It also lets you do full-featured queries, and then it also performs automated analysis so that you get to the root cause much more quickly. All of this data is exposed to you via web UIs and terminal UIs so that you can explore this data very quickly from your own work environment. We also plug into things like Slack, Discord, GitHub, Jira, so you can integrate this data wherever you work. So Backtrace was created as the most advanced analysis and reporting solution today. If you use something such as the other game engines, etc., you may be used to their own existing crash reporting solution, but with Backtrace and using our software, you actually do get the most advanced solution available. And that's because we allow for you to capture the full context, to be able to query against that data, as well as be able to integrate into your existing workflows. People use Backtrace to reduce their refund rates, get their games out faster, and get their teams working on the right things. Instead of worrying about whether or not your telemetry actually reports back crashes, you can actually worry about developing your game and to improve software quality to avoid future bugs. Again, kind of just quickly going over this, our features include very easy integration across all major platforms, engines, and frameworks. You capture the full context of the crash. You get automated symbolification. So for example, if you're used to pulling down a dump into Visual Studio just to be able to view the crash, you can actually not have to worry about that because Backtrace will do this for you. It provides flexible hosting, and it integrates your crash data wherever you work. Here's a sampling of some of our customers. They include Lumberyard, NVIDIA, Streamlabs, Comcast. So if you're developing a game and you want resilient software that's used across some of the most major companies out there, then you can use Backtrace to ensure you're capturing this data. So let's go ahead and kick off the demo of Lumberyard to see what Backtrace looks like in action.
Okay, so just a little introduction. As Abel said, my name's Chris Brunning. I'm a solutions architect for Amazon Game Services. Amazon Game Services offers a wide range of products. We have the Lumberyard engine, there's Amazon Game Lift, which is a scaling solution, and a whole suite of AWS products and services for game developers. Anything from databases to speech generation. We're on the floor here, booth 609, 708, so come over and have a chat. Happy to talk about Backtrace there as well. So what is Lumberyard? It's a free AAA game engine. It consists of millions of lines of C++ code, which we give you. We've been out for 19 months now, classed as beta still. This week we released version 1.12, so that's 13 releases over 19 months. You get the full source, but you also get pre-built versions. With pre-built versions, designers can make games, artists can make games. One of the advantages of that is we can put telemetry, a lot of telemetry in the pre-built versions. It's a complex engine, which makes stability both a challenge and a priority. You can change a couple of lines of code somewhere and make it crash somewhere else for no obvious reason. Obviously that's not a good thing. We want a stable product for our customers. So we spent a considerable amount of effort collecting those crashes that are seen by our internal QA. It's not always obvious that two crashes are the same thing. So we spend a lot of effort sort of deduping them and classifying them as to whether they're what team they go to, a graphics crash or some low-level systems crash. So in the end, we decided to integrate Backtrace because of all the functionality that it offers in terms of deduping and classification and the storage. We're thinking about adding Backtrace as a gem. That's one of our plugins to the system. One of the questions is, if we did, would people use it? I think they probably would, but it'd be nice to get some feedback. So I'll give you an example, actual example of our engine and putting a crash in there. I have to get the right one. That's the one. So over the past week or so, been generating crashes. So this specific one, Backtrace MIGS, has been set up for this conference. At the moment I have, as you can see there, 25 occurrences, 25 crashes in there. Various bits of information here. We have three different GPUs it's been found on. So I'm going to make the thing crash. It's harder than it used to be. We've used this and got rid of a lot of crashes, so I'm going to have to fake one. So this is our editor. Just to show you the game does actually run in here. It's a free game you get with it, first person shooter, to show how you use the engine. I'm going to quit out of that, head down to the console area and actually force a crash when it finally decides to quit out. There we go. So I can fake one. I have a command that I can put in, will cause a crash. So there we go. We have this small program picks it up. Do I want to report it? Yes, I'll report it. So now if I refresh this website, we now have 26 occurrences. So it's a live, real-time crash collection. If I now have a look at what's in there, I can go to Query Builder. So I have 26 crashes here. I can set up my own queries in here. So what I'm going to do is actually do by, I'm going to add by resolution. If I could type at this angle, by resolution. My resolution equals, and these are all the resolutions it's seen on various crashes. We had to change the resolution for this presentation, so not quite sure which one it is. That one, I think. So I've actually got two in there at the moment. And it says it's an invalid write. Okay. I can add extra filters on there, or in this case, I'm just going to jump to debug on there. Because it's uploaded a mini dump, I get all of the call stack here. It tends to be rather deep through all the various Qt parts of it. Console line edit, I was adding stuff in the console. Execute string, and we finally get to this, which is a crash test. That's absolutely fine. I don't know what the code is, so what I can do, because everything's saved, sorry, if I do this, I can get a snapshot. This will have downloaded me a snapshot from the website. It's very nearly there. Okay, that's going to take a little while, so I'll just talk through this a little bit. We get all the information here as well, you know, what the application was, what operating system, various different version information, GPU memory, GPU name, all the device IDs, this kind of thing. I think we're there. It's all because it's associated with Visual Studio. Bring this up and debug in there with native. Right, and it said it was a memory fault, and as you can see there, basically we're writing to an invalid address. It's given me exactly where the crash was very quickly. So with a deduplication of all of the crashes that our QA have picked up, we can say instead of 1,000 crashes, we're actually down to 10 individual crashes, even though they're across different machines, we can identify it, we can go in, we can fix this. It's been an incredibly useful tool for us, and as I say, we're looking to make this more accessible to our users as well. Thank you. I'll hand back to Abel.
Thanks, Chris. Thanks, Chris. Okay, so as you just saw from Lumberyard, they were able to make their game crash. In real time, they were able to see the data come into the system, and then they were able to go through the system to be able to understand the context of the crash, be able to pull in the dump information, and then pull it into their debugger as well so they can see the exact line of code where it crashed. What I'm going to do is actually go through another system to give you a bit more detail into Backtrace. So here we have a specific demo game called Killer Bees. This is what we call our universe view, and the universe view gives you an immediate look into crash activity across all of your projects. Killer Bees is the only game we have loaded here. We see 123 errors, but only 45 of them are unique. Remember, one of the big value adds of Backtrace is advanced deduplication. So we're already telling you that of those 123 crashes that have been reported, only 45 of them are unique. You also get a sense of activity here. So you can see that there was spikes of activity early last month. However, we've kind of teetered off now back into some steady state of activity. We're going to go into the project overview to see a similar screen that Chris showed us that gives an overview of the activity over a project. We're only viewing data over the last week. I'm going to expand this over the last month, but you can see here we can go as far back as 10 years. What's great about this is not only do you get this information across your current version, whether it be alpha, beta, etc., but you can do this across historical data as well. So if a crash doesn't occur very frequently and then comes back up, Backtrace can easily tell you that information. On the left here, you see various attributes. Things like game version, graphics adapter, graphics driver version. All of this data can be encoded within what you report to Backtrace. You can also report your own custom attributes. So for example, some popular media players use Backtrace, and they'll even report which song was currently playing. With Backtrace, you can report which game level was currently be playing, what configuration. All of this information allows you to then filter very easily across activity. So for example, if I only want to see crashes that happened on NVIDIA GeForce GTX 980, I can easily click on this. This is also an interactive typing login. So for example, I can look at all crashes that have affected uname.sysname and Windows NT as an example. When we're doing this filtering information, we still are able to see activity over time. We're also able to see various unique crashes. So for example, each of these rows here represent a unique crash. We see the last time this occurred was 10 days ago, and there's been 6 occurrences of this crash. This looks like a particularly interesting one because it's affected different versions of the game, different graphics driver versions. So let's view details. On the left here, we can see a summary of information of the unique crash, or the crash group. So we know this started happening 4 months ago, but the last occurrence was 10 days. We can see the faulting threads call stack. We can see various attribute information that's been reported by each instance of the crash. On the right in the middle here, we see visualizations of this data. This is not terribly interesting because this is a trend line information, but if I'd like to see this over time, where the x-axis here is time and the y-axis is randomized, I can then color these dots based on different attributes as well. So for example, if I want to see the nature of this across game version, I can easily click game version, and now I can see the distribution of this crash information according to the version that it affected. It looks like it's happening across multiple versions, so this doesn't indicate a highly correlated variable. What about graphics driver adapter? Seems like it's happening across a lot of graphics adapters as well. What about time nature? Is this happening at a specific period of time during the day, some sort of sync with the server, etc.? All of these questions you can easily answer with Backtrace, which acts as your server infrastructure for analyzing crash information. Each of these rows represent an individual crash that's been reported to the system. And so we can see the attributes associated with each of those individual crashes. We can also look for attachments. So for example, if you want to attach config files, log files, let's say an image of what's currently being played at the game at that time, all of this can be attached to each crash report and easily retrieved with the system. This means you get the full context of what's going on at the time of crash, which can be incredibly useful if you're trying to resolve it. As Chris showed, you can download the actual dump, load it into Visual Studio. We can also pull into what we call our web debugger. The web debugger is a very convenient, easy way to see the information inside the dump. You get full access to the call stack across all threads. We also highlight the faulting threads, so you don't have to identify that yourself. We do all automated symbolification. So for example, this last thread here is a Windows system call. What Backtrace did was it retrieved the symbols from Microsoft's public symbol servers and did that symbolification automatically. You also see the attribute information categorized here. This was just a brief overview of investigating a single crash. What if, as a game manager or a producer, you want to say, how affected are my users during startup? What we can do is now go into Backtrace's query builder. And so what I'm going to do is I'm going to back out here and click this second menu, View in Query Builder. The question we asked was, which crashes are occurring during startup. Here we're going to define startup as crashing within the first 5 minutes of the game being started. So what I'm going to do here is I'm going to go back to, I'm going to go to this configuration. I'm going to say over the last month, what I want to do is I want to query process age, which is a dimension that's captured by Backtrace. And again, you can report your own custom attributes depending on what you'd like to capture. I want to say process age is less than 300 seconds. So now we can see 82 crashes have happened within the first 5 minutes of the game starting up. I didn't have to do my own analysis, put it into my own database. I easily just asked this information to Backtrace, and I was able to see an answer very quickly. I may want to see now a distribution of game versions that were affected. I may want to see things like which version of Windows was affected as well by these startup crashes. And so here we can see that these are the different versions, graphics adapter, how many unique graphics adapters were affected. I just immediately ask these questions in my head, and then I can ask a bit of Backtrace to pull this information out. I may also want to see the unique crashes here, so I can type in fingerprint, and then I want to see the call stack associated with each of those unique crashes. And so now we're seeing the call stack associated with each of those crashes. If you're used to debugging a game, you know how tedious something like this could be. You're collecting the dumps itself. You're probably retrieving this from, let's say existing game engine or some other infrastructure. But it's very hard to ask these questions of your data. With Backtrace, you don't have to worry about this. It's provided to you already as built software that's turnkey that allows you to capture this information. We can click on debug, and then we'll go back to the debug view there. And again, we can see attachments from there. So with Backtrace, you can take control of your game crashes and not worry about the infrastructure necessary to report those game crashes. You can strengthen your defenses with true cross-capture, cross-platform capture. You can go on the offensive to be able to do analysis on your crash data immediately and effectively, and then you can gear up your team by integrating this data into your existing workflow systems. If you're interested about learning more, we'll be at our booth 507. Come get some swag. Here's our Twitter account. There's the website. And if you want a t-shirt, we also have t-shirts back there as well. Lastly, before I end off the presentation, I want to thank Amazon Lumberyard for doing a joint presentation with us. It's great to have such a key partner, someone that's building an open ecosystem that provides such great services like Amazon Web Service, etc. And so with Backtrace and Lumberyard, you guys get the full suite of infrastructure that you need to be able to develop the game and focus on producing a great game, not the infrastructure needed to improve the quality of it. So thanks, everyone.